Hello all. In this video, I'm going to take a look at a particular function that we haven't used before, but that is our friend from now on when we're working with images. There's a function in OpenCV that allows us to convert an image from one color representation to another, from one image representation to another. It's one function, and then we just tell it what conversion we want, and it does it for us. So we'll take a look at a couple of examples and the results that come out of those. Again, I'm going to be drawing examples from the readings because those just happen to work really well. Okay, so we have a particular conversion function. It's called cvtColor. CVT is short for convert. So I usually read this as convert color, but cvtColor, it's abbreviated. This takes in two inputs. The first input is an image, and the second is a code that tells it what transformation you want. Now these are, because I'm zoomed in really tight on this particular web page, these are showing up broken up on two lines, but in reality this would be one line. It's not a very long command. So the first example here is showing we're going to take an image. The color code we give it is always cv2.color underscore, and then you describe the transformation you want, and they use the number 2 instead of the word 2 to make it short. So BGR to gray, it assumes it's starting with a BGR image, and it will translate that to a gray image, and it returns a new grayscale image when you do that. There are two other examples that we are likely to use. BGR to HSV. HSV is really handy when we want to do things with color. It's a better representation for identifying specific hues of color, and so there will be times when we need to convert an ordinary image into the HSV format. That's what this code tells it to do. We can also take a grayscale image, even one that's just a single channel, and say gray to BGR, and that will essentially, it just duplicates that channel, that one channel image, and makes 3 identical channels. So it'll still look like a grayscale image. It's just that now it's going to be it'll be the shape of a color image. That's something we might need to do. It's not super important and something we'll do all the time, but I did want to include a couple of additional codes for you. All right, let's switch over to Python and take a look at some examples. So here I have read in one of the coin pictures, and I am just converting that coin image from BGR to gray and then displaying it. That's our first example. All right, now I'm going to switch to the desktop view, and I will run this program. And we'll see the results. So on the left you have the original picture, coins sitting on a red surface, and then on the right you can see that it's been converted to grayscale. It's very convenient. All right, so that's a really simple example. Let's take a look at a slightly more complicated example. So this is not doing much more. It's the mushrooms picture. We've seen this picture before. And we're going to read it in and make a grayscale. That's exactly the same thing I did before. And then we're going to convert it to HSV. And then I'm going to imshow all 3 of them. And it's really what happens when you try to imshow an HSV image that I want to talk about, because it's where things get weird. And that's why this is labeled as weird in the code. And we'll take a look at what happens. So the mushroom picture is here. That's our original mushroom picture. In the middle you can see I converted it to grayscale. That looks about like you might expect. And then I converted it to HSV, and I get this weird thing when I imshow it. What is going on? Well, this is a limitation of the imshow function, and also a limitation of how we're representing images. The imshow function assumes that you are either giving it a one-channel image that is grayscale, or that you are giving it a 3-channel image, which is BGR. If you give it any other color representation, it is not going to replicate those colors correctly. So in HSV, the 0 channel is hue, but it's interpreting that hue as if it's blue. And in HSV, the 2nd channel is saturation, and it's interpreting that here as green. And value is the brightness, it's interpreting that here as red. And that sort of makes sense then if you look at the brighter sections in the picture are really the mushrooms themselves, and that's what's showing up most strongly as red in this last one. So you cannot use imshow to see an image that's represented in a format other than 1-channel grayscale or BGR. imshow does not expect anything else. But you can see that we have in fact changed it to some different format, and we will use that in the future. All right, so convert color is powerful. It's doing a lot of complicated mathematics for us, so we don't have to know how. We just need to know these different codes, the different color codes that exist. There is an exhaustive list out there somewhere, but for the most part, if you know what the color representations are called, you can figure out what it is just by guessing, just by typing the names of the color representations, and you'll probably be just fine. All right, next we're going to go on and talk about thresholding methods. Mostly we're going to focus on two of them, threshold and in range, but we will also take a look at a couple of others that are options you might want to know about. I'll see you in that video or sooner.